So good morning everyone. My name is Nishant Rajadaksha and my roll number is 16010120131. My division is B3. The title of the paper that I've chosen is Supervised Learning on Relational Databases with Graph Neural Networks. And so the paper was published on archives.org. The year of publication is 2020 and the author of the paper is Milan Cvitkovic. So let me begin by giving a brief introduction of the paper. So the author he explains to us that training machine learning models on data stored in relational databases requires significant data extraction and feature engineering efforts. So basically machine learning practitioners they like to work with a column of numbers, and to get the column of numbers from relational databases they generally flatten those columns or try to concatenate those columns. So in these processes they tend to miss out on the information stored in links between different tables. So relational databases they consist of many links between many different tables. So to leverage the whole power of the links between relational databases, the author he proposes to use graph neural networks. So the author proposes an algorithm called RDB. Proposes an algorithm to convert relational databases to graphs, and he proposes that we let graph neural networks further process the information stored in those graphs. So basically, in the literature survey of the paper, the author has given a extensive account of relational databases and research done on relational databases. So let me give you a brief intro. Let me give some brief information about relational databases. So a relational database is a collection of data items with predefined relationships between them. These items are organized as a set of tables with columns and rows. So tables are used to hold information about the objects to be represented in the database. Each column in the table holds a certain kind of data and field stores the actual value of an attribute. So the rows in the table represent a collection of related values of one object or entity. Each row in a table could be marked with a unique identifier called primary key, and the rows amongst multiple tables can be made related using foreign keys. So this data can be accessed in many different ways without reorganizing the database themselves. So here's an example of a relational database. As you can see, we have a patient table, a visit table, and a city table. So a patient table has different columns named patient ID, hometown, or contracted flu. A visit table has different columns like visit ID, visit date, patient ID, and so on. And there are links existing between these tables. So these links are the crux of relational databases. So for example, the patient ID, it acts as a foreign key relation to the patient ID of the patient table. So again, this patient ID it forms a link to the patient ID of the patient table. So again, as you can see, the arrow pointing from the visit table to the patient table, it indicates a link between the visit table and patient table, and there exists a link between the visit table and the city table, and there exists a link between the patient table and the city table, and so on. So this was a brief introduction to relational databases. So again, the author the graph neural networks feature prominently in the literature survey section of the paper. So I'll give you a brief introduction about graph neural networks too. So graph neural network is any differentiable parameterized function that takes a graph as input and produces an output by computing successively refined representations of the input. So graph basically it needs to be a graph neural network is a function which takes into account contextualized embeddings and produces embeddings which are refined based on messages passed by a node's neighbors. So as you know, graph consists of nodes and edges. So a particular node, it takes in information from different neighbors, and according to those information, it can refine its own information. And finally, after taking into account all the information presented by its neighbors, it can give like contextualized embeddings which can represent itself. So this whole algorithm it is termed as a message passing algorithm, and message passing algorithms are the crux of graph neural networks. So graph neural networks basically work on the information passed by its neighbors. And graph neural networks they have to be differentiable because we need to be able to calculate the errors. And it is parameterized. By parameterized, I mean is it has different weight matrices which we can tweak to get an optimal solution to a function. So here is an example of graph neural network. As you can see, I have an input graph. It goes through a layer of weight matrices in the hidden layer, and again it produces refined output. So in the hidden layer, the outputs of the graph are more refined because it takes into account the messages passed by the node's neighbors. Finally, it is passed to an activation function, and again it is passing through successive weight layers to produce more refined outputs. So this final output graph is more refined than the initial input graph, and it takes into account the whole information present in the graph. So again, to take advantage of this graph structure, the author proposes a RDB to graph algorithm. So the RDB to graph algorithm, it basically converts the relational database tables to graphs, and it does so using these rules. It treats a row as a node. It treats a table as a node type. It treats a foreign key as an edge type, non-foreign key as a node feature, and basically in the table given below, the row AAA2 false, it can be treated as a node and of the type patient table, and the edge type can be of the type patient ID of the visit table. So that's how the author has suggested that we build graphs from relational databases. So after building so these are some of the benefits we can receive. Like these are some of the thoughts why the author is choosing the RDB to graph algorithm. And what the author is basically trying to do is, again, it is represented pictorially. He's trying to take all tables, convert them into graph, and then process those graphs using different graph neural network algorithms, and finally output a certain regression or classification value. So in this case, it's a Boolean value, but it can be anything as a regression number. It could be a number or a classification, class number, or so on. So the results achieved by this paper were really good. So on datasets acquired from Kaggle, such as acquired value shoppers challenge, home credit default risk, the graph neural network based implementation performed better than traditional machine learning algorithms and MLPs, multi-layer perceptrons. The only case where it did not perform better was in the case of KDD Cup dataset. So basically, the author proposes a novel method to harness the information stored in the relational databases for the purpose of supervised learning using graph neural networks. The author describes an algorithm to convert relational databases to graphs and to prune the graphs to create optimal subgraphs. These subgraphs can later be fed to graph neural networks to refine representations. Finally, these representations can be used for graph classification tasks such as node prediction tasks, link prediction tasks, etc. The future scope of this paper is that we can leverage transfer learning, which is not really used that much in graph neural network domain. So transfer learning is really popular with transformers and so on. So we can use transfer learning for graph neural network domains, and we can achieve better results, and we can design specific graph neural network based structures for relational databases. So that is the future scope of the paper, and these are some of the links I've used to make this PPT, like some of the definitions I've picked up from those links I mentioned in the bibliography. And that's it for my project. Thank you.